11, 7 is finite differences. Remember that y equals f of x is a polynomial so it's a polynomial function of degree n if and only if the nth difference, and you guys all know that difference, what does difference means? Subtraction, yes. So the nth difference of the corresponding y values are equal and non-zero. And remember, that's the exact same thing I just said. So we're going to subtract, and remember that you have to subtract from what to what? Right to left. So you remember to subtract. That's the key thing. So subtract right minus left.
I like your definition better.
Yeah. But the biggest thing is just we're going to have to keep subtracting until they equal, and they have to be non-zero. All right. Example. Determine whether the values can be described by a polynomial function. And for this purpose, we're going to put a degree less than 5. Because we don't want to have to keep subtracting more than 5 times. So we're going to say degree less than 5. If so, give the degree. Alright. So we have here the first one we're doing, and we're going to do A, B, and C so that we don't have to keep writing this part, but this is all we're doing on all of them today. That's what we have to do. So we're going to determine if it's a polynomial. If it's a polynomial, what degree is it? So my x values. The biggest word is corresponding. That means that you have the consecutive numbers. So my x values are 1, 2, 3, 4, 5, 6. My y values, and this is given, are 11, 12, 15, 20, 27, 36. Now, because the biggest thing is it says corresponding. That means that you have to have them consecutive. All right, so if they don't give you consecutive numbers, it's not going to work. So they have to give you consecutive numbers. So you always go to your y values. This only is there to show you that it's consecutive numbers. So now you go to your y values and you subtract from right to left. So you take your right number, so you have 12, and you subtract 11, which is 1. 15 minus 12, 20 minus 15, 27 minus 20, 36 minus 27. And I'm going to, that's my first time subtracting. If these were all the same, it would have been degree 1. All right, I want you now to subtract the next row. Hopefully you got 3 minus 1 gives you 2. 5 minus 3, 2. 7 and 5, 2. 9 minus 7 is 2. So this was my second time subtracting. So this, and they're all the same. So that means it's degree 2. It's degree 2 because it's my second time subtracting, not because they ended all being 2s. That just is a coincidence. Alright? They could be all 3s, they could be all 6s. It's the second time through subtracting. Alright? Alright, I'm going to give you one now to try. So we're going to call it B, so we don't have to write the directions again. My x values are 1, 2, 3, 4, 5, and 6. My y values are -5, 0, 1, 4, 15, 40. The only thing I'm going to help you with the first number, because this is as tricky as it ever gets. 0 minus a -5, so that gives you 5. I just want to make sure that you guys make sure you look at your negative signs. So when you go through and subtract it, see if you can figure out what degree it is. You have to start over here, guys. Don't start to the 40. You have to start here. So this is my first subtraction. This is my next subtraction. That is my next subtraction. You have to work it this way. You can't come back over here. Make sure you work this way, or else you won't do it right. Make sure you work it 2 numbers at a time. Yep. Yes. Yes, and that's why, because you know how it says, well, if you think about it, because you're subtracting, so you're going to have one number less each time. The other thing is, when it says degree 5, since it says degree 5, that's why they have to give you 6. So if it's possible to go all the way up to 5, they have to give you one more, because if they didn't, you would run out of numbers. Yeah. Yep. All right, anybody need more time subtracting?
I do.
All right, Kelsey, what did you get for your second row?
My second row?
Yep.
5, 1, 3, 11, 25.
Very good. So now, what can I say that this is not? At this point, I can say that it's not a first degree. Yes, I can say it's not a first degree polynomial. David, what'd you get for the second row? -4. 2. Very good. So I know at this point that it's not a second degree polynomial. Billy, what did you get for the third degree, or third row?
6.
Very good. So this is a third degree polynomial. So this is degree 3.
It's a polynomial because it's the same 3 numbers.
It's if it's ever the same. Like the last one was
4.
all 2s. Yep. So as long as if it was 7, 7, 7, 7, 1, 1, 1, 1, as long as they're the same, when after you subtract, if this wasn't, then we would have subtracted again. If these 2 would have been, then it would have been degree 4. All right. Yep.
You should make this the biggest grade in the chapter 11 test.
Yeah.
At least a quarter of the question.
At least a quarter.
Do your subtraction.
All right. So C is A1 equals 6. A of n is equal to 2 times A n minus 1 plus 5. What they are doing now is they are giving you a recursive formula, and we have to get our numbers. So all we have to do now is we still have to do an XY chart. We want to know, is this still a polynomial? So remember, I'm going to find my first number, my second number, third number, fourth, fifth number, and sixth number, because you have to have a consecutive, right? So what is my first number? 6. What is my second number? It says you go 2 times the previous number. So 2 times 6 is 12, plus 7, or plus 5 is 17. So now it says 2 times the previous number, so 17 times 2 plus 5, 39. 83, 171, and 347. Alright. Oh yeah. I want you to see if this is a polynomial. I want you to
Oh, that's gonna be close.
use your calculator if you need to.
I'm going to. No, I don't remember anything. Are you gonna do this now, or is it- No.
Huh?
I left my calculator.
That's funny.
Well, it better not take 8 years. Gosh, I'll be like old by then. Yeah, there shouldn't be any negative numbers.
He's getting all the wrong numbers, but they're negative.
Hmm?
He's getting all the right numbers, but they're
It
negative.
doubles every time.
Mm-hmm.
11, 22, 44.
Yep.
These is like the same numbers over and over again.
So what does that tell you?
It doesn't agree.
There's not, it's never gonna, right? Because it starts that pattern, right? So you had 11, 22, 44, 88, 176. 11, 22, 44, 88, 11, 22, 44, 11, 22. So, you guys you see that remember if I would have, because this is a pattern, so that means that this would continue on forever. If I'd have more sheets of paper and more time, this pattern is all throughout the whole thing, isn't it? So, we can say that this is not a what? Polynomial.
Polynomials is a silly word.
All right, take out your homework from yesterday.